4. 50-point test. There's only a total of 8 problems on the test. It's 3 pages long. Okay? It's a short test. It's not a long test. Each problem is worth around, like the multiple choice are worth 2 points as always. And each problem after that is worth like 6 or 7 points per problem. There's a good amount of work to each of these problems. So I think we should do at least, an example from each section and go through all the steps, because there's not that many sections to work on. All right, the reason it's much shorter is because one of our days in this class was that lab we did with the springs. Another day you worked on your group projects. So those are like another full section that we may have gotten to, but I didn't want to push it because the next test we're only going to have, we have 2 textbook sections left, 8.5 and 8.7 we're going to do, and then we're going to do like 2 or 3 lessons that are not in your textbook, but that are good things for you for pre-calc and calc. Okay? So we're a little bit ahead of the year plan, which is good. So 8.1 through 8.4. 8.1 was what kind of variation? Anybody? Direct. Okay? Direct variation. 8.2 was a combination of direct and inverse or indirect. Okay? So let's start with a problem where I'm giving you like a word problem with a lot of variables, then a word problem with more of an application base. So let's say the following. Okay, let's say if R and S are directly related and R equals 30 when S equals 8, then determine, then determine the value of S when R equals 42. Now, I can make this easy and make R 60, right? And then it's just double and double. That's very simple. So you would know the answer would be 16 off the bat. But since we're going from 30 to 42, it's a little bit different. You can't just say, okay, R is doubling, so S would double. It doesn't work that way. And I purposely pick numbers so it won't work that way. So I want you to start with your direct variation equation, which Worth will tell us what that is right now.
Yeah. Y equals mx.
Good, or in this case, with these variables,
R equals mx.
yeah, and we use k for our constant, but m is fine. Okay, it's just some variable. It doesn't matter what it is. So we see right away that says if R and S are directly related. As soon as you see that, feel free to underline this. This is this right here at the bottom. Okay, that's the part that you have. If R and S are directly related, that tells me right away R equals KS. Or S equals KR. Either way is fine. Either way is fine. I got to keep emphasizing that. Now, it's not fine if you have direct and inverse variation in the same problem. You can't just mix things around then. But if it's just 2 variables being directly related, you could write that as R equals KS or S equals KR.
Being directly related.
Yes, directly related. Even inversely related, it works as well. Okay, because you would just switch the locations of them and it still works. All right? Anyhow, let's continue this. Now, we're given some situation. We're told that when R is 30, S is 8. Use that information before you try to get the answer. What can I get from the information that R is 30 and S is 8? What can that allow me to solve for or to determine in this problem? Summer? K, very good. So let's go ahead and plug in. All right? We've got R is 30, we've got K there, and S is 8. How do I get K, everybody? Divide, okay? It's going to go in what? Let's see. 3 times 375?
3.75.
Yeah. 15 fourths? Good. All right, so that's what K is. I would write K as a decimal, but you could write it as a fraction because it's kind of like a slope. So if you want to leave it as a fraction, that's fine. It doesn't really matter. Okay? So we've got the K value. So this was our generic equation a moment ago, wasn't it? The generic equation for direct variation. Now that I've got K, what can I write?
You can, now you can solve for S, right? Yeah, so you can do 42.
But just tell me the equation first. R equals now.
R equals 3.75 S.
Good. And then,
And then you can just plug in R, which is 42,
to determine
to determine S.
S. Determine the value of S when R is 42. Arthur, the reason I paused you there was because what I would do now is if I wanted to get S, I would solve generically first. I would divide by 3.75, and I would write it like this. I'd say R over 3.75 is what S is equal to. That's the solution. And then I'd plug in for R, but it doesn't make a difference either way. Okay? But yeah, let's plug in for R. Okay, let's plug in for R either way. Plug in for R right here for 42 and then divide by 3.75, or divide it first like this and put a 42 in its place. Okay, so replace R with 42. What do you get? Yeah, I know it's going to be messy. That's fine. 11 point. Just 11.2. Perfect. And let's think about this for a second. Make sense of your answer. When S was 8, R was 30. Didn't R go up to 42? So shouldn't S be bigger than 8? And we got 11.2. Use sanity to make sense of your answer. Like, think about it. It doesn't make any sense if it went down if they're directly related. So if this is multiple choice, and two things are directly related, and one of them goes up, and then suddenly one of the choices would be only right if the other one went down. That doesn't make sense, right? So rule that choice out right away. Again, if one of your multiple choices was S equals 4, well, S was 8 earlier, how could R go up and S go down? It doesn't work that way when things are directly related. So if the answer you got was anything less than 8, right away you should know it's wrong. Because as one goes up, the other goes up. That's the idea of direct variation. As something increases, another thing also increases. Alright? Let's do one more like this, and I'll show you why, and then we'll do a word problem or two. Okay? Yeah, Ida.
Is this the same thing as setting up those proportions?
Yeah, but here's the problem. I recommend do not use proportions because it doesn't work for joint variation, and it doesn't work for something that's directly related to the square or cube of another number. So I would absolutely recommend don't use proportions. If you want to check the basic ones that are just two variables and they're directly related, you can check with the proportion. Yep. Okay. So let's look at this. If A is inversely, so we'll do inverse now, related to the square of B. Let's say square root actually. Make it harder. Square root of B and A equals 5 when B equals 36, then determine the value of B, which makes it tougher on us because that's under square root. Determine the value of B when A is equivalent to 10. And Ida, this is a perfect example of when proportions wouldn't work. You see how this is like doubling? You want to use proportion or something like this? And it's inversely related, so actually you can anyway. But had it been directly related, and this number doubled, you might suspect that this would double, right? But it won't double, because it's the square root of B. Okay, so whenever it's not directly related to just the variable, that proportion idea won't always work. It will work if you tweak it a little bit, but that takes a little more thought than this. This is actually a much easier method. So give me the generic equation to start with. What is the generic equation, Chris?
A equals K over square root of B.
Very good. Absolutely right. If A is inversely, so it's K over, related to the square root of B, so we put a radical B in the denominator. Very good. Now, I'm given information that when A is 5, B is 36. So what should I do? Yeah, plug it in. When A is 5, B is 30. I was very nice, I know. B is 36. Square root of 36 is? And I have to move it up by multiplying, right? So again, we plugged in a 5 for A, a 36 for B, making this 6 down at the bottom. multiply up. K is just 30. Torment.
So, I'm confused because it said inversely proportional.
To the square root of b.
So if it was just inversely proportional, it would be A equals K over B.
Correct. Yep.
Because,
Absolutely right.
And so so like, it says.
Whenever it says inversely, that other variable goes in the denominator always.
But how,
Because it said square root of b, you put a radical around it. Had it said inversely proportional to the cube of b, it would be b cubed. Or inversely proportional to the product of b and c, it would be a bc down the bottom. The product of b and c. So it can be worded any way. When you hear inversely, you know it goes in the bottom, and then you need to determine if it's a radical, if it's squared, if it's nothing, if it's the way it is.
but how do you know which one, like, that's so confusing. How do you know which one goes in?
Okay, what I always do is, the first thing that's stated goes on the left side of the equation. It started by saying A is inversely proportional. So start with A on the left-hand side. Is that a good trick? Yeah, it always works well if you do that.
Or inversely proportional.
Okay, same thing as indirectly related. If it says it's indirectly related, inversely proportional, indirectly related, same terms. Or inversely varying. All right, we've got K. What do we write now that I've got K?
Plug it back in with when A equals 10.
All right, so we write it this way, good. And now we're going to figure out when A equals 10, how to solve this equation down here when A is 10. Now, I can move stuff first before plugging in A also, right? That's another way to do it. I can plug in A. Whatever's easier for you. Chris, what would I do in this part?
You can divide or multiply by b and then, or switch a and b.
Yeah, switch A and radical B, right? Remember, you're trying to find out what B is, aren't you? The goal is to figure out the value of B when A is equal to 10. Now let's plug in, or we can get rid of the square root first, whatever's easier, right? How do you get rid of a square root around B? Everybody.
Square.
Yeah, just square both sides. Okay? 30 squared over A squared, or 30 over A, quantity squared. Either way is fine. What do we get as a result? A was 10, right? So you get 900 over 100, or just 9. Okay, so you could do 30 over 10 first, get 3, and then square it. Either way, you'll get 9. Okay? Does that make sense?
Can we do one with inversely and directly?
Any flaws? Kill me. Is that? This is A2. It's a combination of A1 and A2, because inversely related was A2, but A2 was also both direct and inverse. So these are all kind of together in A1 and A2. Let's do one, let's do a word problem with direct and inverse variation in the same problem as well. All right, I got it. The electric field experienced, you want to write this down? I know what it is, so I don't have to write it, but you might want to write it. The electric field experienced, E, call that capital E. The electric field, capital E, experienced. Experienced? Yeah, like as a verb. I guess, is that?
I don't know.
Bringing English into math.
Past tense though. But yeah. Electric field experienced, capital E, is directly related to the charge Q. So the Q is the label I'm giving you. I'm telling you the variable to use. So the electric field E experienced is directly related to the charge Q of the particle and inversely related to the square of the distance R from the source.
I did not get that.
Directly related
Square root.
directly related to the charge Q of the particle and inversely related to the distance from the to the square of the distance from the source R. Not square root, the square of the distance from the source R. Okay? Distance from the source R. Let people take a minute. Try and come up with the generic equation in a moment. So I'll repeat what last part.
After inversely related again.
And inversely related to the square of the distance from the source r.
Okay.
Okay, the square of the distance from the source r. I'll combine them.
Can you repeat it, once more, just
I'll probably, you know, I have a test, like maybe last period, so let's see. I didn't make you have, you can pick your own variables. I didn't write variables on there. So if you see like the word speed or velocity, use S or V or whatever's on there. The only reason I didn't is because some people get confused with it.
Mr. You got a last test and you should be
Perfect test. Raise your hand up and look at it if you're done.
Wait a second.
Good.
Yeah. We made me do the math. And then it was okay.
Good. I don't know why you wrote QK, it's KQ, but it's the same thing. It doesn't matter, but traditionally you're right.
No, they must be out, I'm sorry.
Good.
We're not waiting 1 second.
I want you to see if I was wrong. Wait, I don't think Mr. Howell is this. Will this be right?
Good. All right. Hey, if you're still working, take another moment. All right, that's what we've got. Now, if I tell you a condition or a statement, you're going to plug in, solve for K, the same process. Do we need to do that again, or can we just practice this kind of stuff? Right? This is what I think people need to practice the most, is coming up with the original equation. Once you're given a scenario, your next step is to automatically find K. So you'll be given the field, you'll be given the charge, you'll be given the distance. Okay? There'll be units on them. Don't let the units confuse you. Write the numbers in without units if you want to, but at the end, when you're asked to find the distance, make sure you put units on that. So if I tell you that the electric field is 20 newtons per coulomb, the charge is 30 coulombs, and the distance from the source is 5 meters, you find a K value, right? Then I'll say, well, now the electric field is given as this, the charge is given as this, find the distance from the source. Your answer, say your answer is 8. Your units need to be meters. So whatever units you started with, you need to answer with. But in the problem, if you don't want to use the units, you can drop them. You follow what I'm saying?
Yes.
Okay, so mid-work, if you want to just plug in the numbers I give you, that's fine. But at the end, if you're solving for R is a distance, its units should be meters. If I give you the units for Q, which are called coulombs, it's going to be the same units in the answer if you're solving for Q. So even if you don't know what a coulomb is, it doesn't matter. Okay, so if I say the charge on the particle is 12 coulombs, you're going to plug in a 12 coulombs here to find K. So when you find the answer at the end, say you find the charge, the units are still coulombs. Who cares what they are for now? I mean, it is important, obviously, in physics, but as far as math right now, that's not the important part. The idea is that you're understanding where you put numbers. Okay? Let's try another one. Okay? Let's try another one. Let's say...
Maybe like
the volume...
all ones on this?
And the lamp.
The volume of a cylinder, is, so right away I should see V equals, right? The volume of a cylinder is directly related, I could also say jointly related because I'm going to have a product. Directly related to the product of the height of the cylinder and the square of the base radius. It is directly related, the volume is directly related to the height of the cylinder, the product of the height of the cylinder, and the square of the base radius. Check with your neighbor if you're done. If they're done also, though, don't bug them too much. So I could say jointly related in the problem, or I could say it's directly related to the product of. If I said it was jointly related to the height and the square of the base radius, when you hear jointly, you're talking about the product in the numerator there. Right? Good. Right. And the parentheses aren't even needed, right? It's associative and commutative both. Good. 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 What is the pi is involved in there? Is that what you're thinking about? It has a K as a being pi over 3. Oh no. K as a being pi. A cone is pi over 3. Very nice. Good. K. Where's your K? Don't forget your K.
You only.
K
variables.
R squared. K H R squared.
I got it.
You can use R or B for the base radius. Either's fine. Doesn't matter. Hey, others on the other side know this now, so don't answer. Anybody that doesn't say it. What is K in this problem? Anybody know what K equals? Without even giving numbers. What is it?
K would equal pi.
Who said it? Yes, pi. The pi with the cylinder is pi R squared H.
No, what is K?
A cone would be K. A cone K would be pi over 3. 1/3 pi R squared H.
So then K equals pi.
Yeah, I mean, in this kind of a problem, if I gave you numbers, you'd end up solving for K, and it'd probably be like 3.14. You follow what I'm saying? So you know.
The volume of a cylinder is K.
Is pi R squared H. Alright, let's go to A3 and A4. We have 15 minutes still. It's examine B-Day. Okay, we have 15 minutes. So A3 was long division, but it's examine B-Day. So we got till 2:30. Hey, you know, it's really cool because you can make up any problem for this and practice on your own. So somebody give me a polynomial. Something with x to the 4th power at least. Something x to the 4th.
X to the 4th plus 2x to the 3rd.
And she's giving it in order, but obviously it needs to be put in order if it's not given in order. Continue.
Plus 2x to the 3rd plus x to the minus.
Just skip one of them somewhere.
Oh, okay. Minus x plus 2.
Plus 2, does that work, Jordan?
And can
So what did we miss? So what do I put in for x squared if it's not given?
But can like not give it in the divisor, right?
Yeah, the divisor could be a polynomial, it could be a binomial.
Like 4 and then x or something like that. Something that's not just like x. Because there's one in like the problem set.
Yeah, let me think. The only problem is if it's 4x, you're going to get all fractions.
It's going to be 4x, just like something.
Well, then I need to put a coefficient here then, at least. So we'll make this coefficient 4 in the front. Okay, make that coefficient of 4 in the front. And then let's make this 2x plus 4. Okay? Or you know what? Here, let's make it even harder.
I like harder. You can do it. Let's do the problem. 2x plus 4.
Let's put something in front of it though, instead. Here, I got a better idea. Let's make that a 3. Let me just rewrite this.
Oh, 2x squared plus 3.
Let's make it a quadratic.
Oh, I see. This one's stapled backwards.
Okay? Alright, so our divisor is 2x squared plus 3x plus 4. Our dividend is 4x to the 4th plus 2x cubed plus 0x squared minus x plus 2. Okay? It's a lot going on here. You are not going to use synthetic division for a problem like this. Why not?
I don't know.
Why can you not use synthetic division, Liam, in this problem?
It's too hard.
No, that's
There's no device.
It doesn't say do synthetic division.
you can't do a quadratic.
Yeah. The divisor needs to be, as Austin just said, a linear term. So if it were just x plus 4, we can do that. Okay?
Yeah.
I'm not going to make it like 3x plus 4 if you're using synthetic. If it's synthetic, it will be just like x plus 2, x plus 5, x minus 4. And there's a reason for that you'll see in 8.5 and 8.7. That it doesn't, we're not going to look at like...
It was a problem like that, and I tried to do it, and I was like...
Was it in the problem set?
No,
Okay.
it was one of these, and it was like 3x plus 4, and I was like...
With
why is
synthetic,
this
it gets
not
messy. It gets real messy that way. Ida. You could, but it doesn't affect it because remember, once we put a number up top, don't we multiply it to all these terms and then put them below? Remember how you do long division? You put the number up top, you multiply it, distribute it, write them all below, subtract it. So if there was a 0x there, and you multiply 0x times anything, it just becomes still 0x.
Wouldn't it take the place of one?
Yeah. So as a placeholder it would be helpful, but you really don't need it. Let's do that though. You want to do that to make it so it makes it a little more...
When you multiply, like if there was a 0.
I get what you're saying for sure. I'm saying you don't need it there, but you could have it there. This one you need it there though. You must have it. Let's do what Ida said. Erase the 3x in the middle, please. Make it 2x squared. Make it... I know.
It's a good problem.
Sorry, but look, this is a good one. Make it 2x squared
Somebody said the problem.
plus 3. Okay? So what Ida's saying is, what if there's no middle term? Do we have to put a 0x there in the divisor? Do you see what I'm saying here? There's no x term in this divisor anywhere. Do you need a 0x? You really don't, as long as you remember how to multiply correctly and put it in the right spots. And let me show you what I mean. So how do I get 4x to the 4th? Or what do I multiply by 2x squared to get 4x to the 4th? To get 4x to the 4th worth?
2x squared.
2x squared. Now, I take 2x squared and I multiply it by everything in the divisor. When I multiply 2x squared by 2x squared, I get 4x to the 4th. But then when I multiply 2x squared times 3, what do I get?
6x squared.
That goes here.
That's
Because they have to line up. Ida, this is your question. If there was a 0x here, it would be obvious because you'd put the 0x cubed right here, right? But this 2x squared times 3 is 6x squared. It's got to go here. What goes here? Nothing. So just leave it. Okay? You're still going to do 2x to the 3rd minus nothing. Okay, keep that in mind. This quantity still is here. And we're subtracting the entire thing. If you want to, do this. Put a plus 0 there, please. It might help you to put a 0 there as a placeholder. You don't need it in the divisor. That's what I'm saying.
Then you skip a whole one. So next one.
That's the key. You need to literally skip the entire column there and go over to here.
I just realized that when I tried to do the next line.
So 4x to the 4th minus 4x to the 4th is?
0.
Thank you. So it cancels. 2x to the 3rd minus 0 is? 2x to the 3rd. You can't forget that. That's the thing. If you don't put that 0 there, some people forget this is still here. Okay? So 2x to the 3rd minus 0 is 2x to the 3rd. 0x squared minus 6x squared, negative 6x squared. Now, what do we bring down? Yeah, bring down the negative x. It's just like long division like we did last time. Okay, it's the exact same thing.
Except it's not the same thing because it's hard.
It might be a tougher problem, but it still is the same idea. Hey, before you keep going, together, let's do this next part. What variable or number goes up here, so when it's multiplied by 2x squared, it becomes 2x cubed? That's the question you always ask yourself. What goes here, everybody listen, look up. What goes here, so when it's multiplied by 2x squared, you get 2x cubed. What needs to go up here? What needs to go up there? Chris, what do you got? Just x. Because x times 2x squared is 2x cubed. Then x times the missing 0 in the middle is still going to be 0 here. Then x times 3 is 3x. And I remember I need to subtract the whole thing. Okay, so negative 6x squared minus 0, well that's just negative 6x squared. Negative x minus 3x is negative... Hello? Negative x minus 3x is?
4x.
Negative 4x. We need to be able to subtract, positive and negative numbers. Now, at this point in time, we can go further. We got one more step to go. Look at the dividend, or the divisor. What is the degree of the divisor?
Square.
It's squared, or it's a second degree. What's the degree of what I've got left down here?
Second degree.
So I can still keep going. If at any point in time, the divisor's degree becomes greater than what you have left over, you have to stop there. Okay?
Oh, I see. There's no mistake.
So what has to go up top here? What number? Clearly it's like second degree, x to the first. This is just going to be a constant. What constant goes here? So when multiplied by 2x squared, we get negative 6x squared.
-3.
Negative 3. Let's try it. Put a negative 3 up top. Okay, take the negative 3, multiply it by 2x squared. You get negative 6x squared, which is exactly what we want to get. Remember, we always want to get whatever number's there, because in the end we're going to be subtracting this whole thing. Then we have to say to ourselves, all right, negative 3 times 3 gives me negative 9. That goes right here. Oops. Got to bring down my 2. Whoops. Forgot to bring down my 2. I forgot about the placeholder. See? I apologize. Okay? Bring down the 2. I apologize. Bring down the 2. We have to consider a 0 placeholder from that missing term in the quadratic. And then the negative 3 up top times the 3 gives me this negative 9. Negative 6x squared minus negative 6x squared is 0. Negative 4x minus anything with a 0 is negative 4x still. I'd have to keep moving it like that or no? 2 minus negative 9. Alright, now, I stop here. Why do I stop there?
Because 2x squared, the degree is higher than the...
Exactly. This degree here is 4x, or the degree is 1. The degree of the divisor is 2. As soon as the degree of the divisor, x squared, is bigger than just x, you stop, and this becomes your remainder. Yes, so take the answer up here, the quotient, write it down. 2x squared plus x minus 3. Then take the remainder, so plus the remainder, which is negative 4x plus 11, all over the divisor, which was 2x squared plus 3. So again, you have your quotient plus your remainder over your divisor, always. I'll tell you right now, just to make you feel a little more comfortable, I'm not going to give you one with a missing term with a quadratic in the divisor. Okay, but I'm glad that we can show that we can do that. So Ida's question was great. We can see that occurs. But if you do, and I'll tell you now, you will have something like x to the fourth divided by a quadratic, but it'll be like, x squared plus 2x plus 5. Okay, the quadratic won't have a missing term in the middle of it. What if the remainder were 0? What if the remainder were 0, Liam? Then the divisor and the quotient are the factors of the dividend. Write it down. If the remainder is 0, if r equals 0, then the divisor and the quotient are factors of the dividend. Dividend. And just to prove it, let's look at this example. 6 into 42, it goes 7 times in. 42 minus 42 is 0, remainder is 0. So if the remainder is 0, I'll point as I make the statement. If the remainder is 0, then the divisor and the quotient are factors of the dividend. Divisor and quotient are factors of the dividend. Now, let's do one example of synthetic real quick, but I need to mention one thing. Remember, obviously, this part I just said for sure. You need to also be able to, if I give you a problem with long division and the divisor is binomial, you should be able to do it with synthetic also. Right? You should be able to do it both ways if you're given a monomial divisor. So if the problem says this, say this is, alright? Say that's the problem. And it's clearly not factorable, it doesn't work, so we have to use long division or synthetic. I might say to you, choose either one. I might say, do this both ways with long division and synthetic, proving that you get the same remainder. Okay, to show that you get the same answer. Let's do this with synthetic. What goes on the outside right away? 5. Because remember, this is like x minus c. That's what this is right here. So c is just 5. Okay, let me move this down a little bit. Just get rid of this crap. All right. What goes on the inside? 2, 4, negative 7. Okay. Oh, not on the inside, on the top. Sorry. The coefficients always go up top. The result goes on the inside for this. Keep watching if you want to. Keep watching. Bring down the 2. Shh. Okay, that's fine. Multiply and add, giving you 14. Multiply and add, giving you 63. Giving you an answer of 2x plus 14 plus 63 over x minus 5.
You're not going to try and like trick us.
I'm not tricky.